I am Johnny Rose Roll. So for today's video, we're going to prove the cancellation laws for a group G. So suppose G is a group and we have three elements A, B, C, and G. 1. If AB is equal to AC, then we can cancel the A's, hence the name cancellations law, and we get B equals C. Likewise, if AC is equal to BC, then we can cancel the C's, and so we get A equals B, hence the name cancellations law. So let's go ahead and prove both of these. So, proof 1. To prove 1, we'll start with our hypothesis. So, suppose that AB is equal to AC. And now, we have to show that B is equals to C. So then, we'll start with B and we'll just go through a series of steps and show it's equal to C. So, we somehow have to use our hypothesis that AB is equal to AC. So, the natural thing to do is to try to insert an A here, where this arrow is on the left, so that we can use all hypotheses. In order to do that, we'll insert an E there so you can write this as EB. And this because E is the identity element. That's why the step is true. And now we want to insert A there, so one way to do that is to use the fact that A is in G, and so it has an inverse. So we can write this as A inverse A times B. And this because A inverse is the inverse of A. And A is in a group, and so every element has an inverse. In particular, A has an inverse and its name is A inverse. Then we can use as associativity to write this as A inverse parenthesis AB. So this is by associativity. And we know AB is equal to AC. Alright, that's by hypothesis. This is A inverse parenthesis AC. This is by hypothesis. And then we can use a sensitivity one more time and write this as A inverse times C. This is by associativity. And then A inverse times A. Well, we know that equals to the identity element. That's because A inverse is the inverse of AC. This is because A inverse is the inverse of A. And EC is simply equal to C. because E E is the identity element. Because E is identity, so we just justified every single step. And in your mind, you should at least know what's going on in every step. So we showed that B is equal to C. That proves 1. Let's go ahead and prove 2. Suppose AC is equals to BC. We have to show that A is equals to B. So claim A is equals to B. Then we'll stop our writing down A, and we somehow have to show that it's equals to B. So do is put the identity there first. We can do this because A is identity. So do this, put the identity there first. We can do this because E is the identity. Then we can put AC there by writing it like this. C inverse C inverse, and we can do this because C inverse is the inverse of C. Then we can use asset, so we can write this as AC times C inverse. Then we can replace AC with BC times C inverse. So write this as B CC inverse, and then B times E is equals to B. That's because E is the identity. So we showed that A is equals to B. So let me go and fill in the steps. Here's the first step was because E is the identity. And the second step was because C inverse is the inverse of C. And the third step was by associativity. And the next step is by hypothesis. The next was by associativity. And this one here is because C inverse is the inverse of C. And the last one, because E is the identity. So, that's it. We proved the cancellation loss.